This is the third class of manufacturing process module 2. In this section, I am going to discuss about arc welding process. Basically, arc welding is a fusion welding process. In fusion welding process, at the interface of the metal piece to be jointed, there will be fusion take place. A molten phase or liquid phase will be present. In arc welding process, heat required for welding is obtained by obtained from electric arc created between the electrode and the base metal to be jointed. That's an important point. In arc welding process, the heat required for welding is obtained from the electric arc created between the electrode and the base metal to be jointed. See, electric arc is created by AC or DC power source. Power source used in arc welding is AC or DC power source. See, when a high current is passed between the air gap between one conductor to another conductor, that means electrode to workpiece, it produces very intense and concentrated heat in the form of spark. The temperature of the spark is almost 3600 degrees Celsius, which can melt the base metal. So during welding process, the electrode is uniformly moving towards the workpiece and hence keeping a constant gap between the electrode and workpiece, and also at the same time the electrode is moved along the desired line of welding. So on solidification, it form a joint between the parent metals. So this is the principle of a arc welding process. Once more, arc welding is basically a fusion welding process in which the heat required for welding is obtained by the electric spark or electric arc created between the electrode and the base metal to be get jointed. When the current is passed between one conductor to another conductor through an air gap, it produces very intense and concentrated heat in the form of spark. The spark have almost a temperature of 3600 degrees Celsius, which can even melt the base metal. So during welding process, the electrode is uniformly move towards the workpiece, and also the electrode is moving along a desired welding line. On solidification, a good welded joint is produced. See, the arc welding process, the power source is AC or DC power source. In arc welding process, two type of power source will be used: straight polarity and reverse polarity. Straight polarity, it is also known as direct current electrode negative, and reverse polarity, it is also known as direct current electrode positive. So first of all, straight polarity. In straight polarity, electrode is connected to negative terminal and workpiece is connected to positive terminal. Straight polarity, electrode is connected to negative terminal and workpiece is connected to positive terminal. Straight polarity is also called direct current electrode negative. In the case of straight polarity, 70% of the heat is produced on the workpiece and 30% of heat is produced in the electrodes. In reverse polarity, electrode is connected to positive and workpiece is connected to negative. Reverse polarity is also known as direct current electrode positive. In reverse polarity, 70% of heat is produced in the electrode and 30% of heat is produced in the workpiece. That's the difference between straight polarity and reverse polarity. Actually, for welding thin workpiece, reverse polarity will be used because 30% of the heat will be only produced on the workpiece. So that is the straight polarity and reverse polarity, direct current electrode negative, direct current electrode positive in the case of arc welding process. So arc initiation, how arc is initiating in a arc welding process. Arc is initiated by providing a conducting path between the electrode and the job or by ionizing the gap between the two. There are two methods for producing arc between the electrode and workpiece: by providing a conducting path between the electrode and the job or by ionizing the gap between the two. So this can be done by several methods. First method, a momentarily touching the electrode with the job and taking it away. So this is the electrode and this is the job. Suddenly touching the job and taking it away. The arc will be initiated. By scratching the electrode with the job. You can see scratching the electrode with the job. Third one, by keeping steel wool between electrode and the job. Keeping a steel wool, that's a conductive path between the electrode and job. This method is using submerged arc welding process in order to create arc between the electrode and workpiece. In automatic welding arc can be initiated with the help of carbon rod. So a carbon rod that will touching the electrode and the workpiece simultaneously and producing an arc between the electrode and workpiece. So these are the common method of arc initiation in arc welding process. Next one is arc welding electrode. See, electrode used for arc welding are classified into consumable electrode and non-consumable electrode. So what's the difference between non-consumable electrode and consumable electrodes? Non-consumable electrodes are which is not consuming during the welding process. See, when the electric arc struck between the electrode and the workpiece, in the case of non-consumable electrode, the electrode does not get melted. In TIG welding process is a non-consumable electrode will be using. One of the example of non-consumable electrode welding process is the TIG welding process, tungsten inert gas welding process. In the case of consumable welding process, when the electric arc struck between the electrode and the workpiece, the electrode end get melted and the material is transferred into the molten weld pool through the welding arc. So that's the basic difference between non-consumable electrode and consumable electrode. So consumable electrode. See, in the case of consumable electrode, the electrode get consumed during welding process. When the electric arc struck between the electrode end and the workpiece, the end of the electrode get melted and the material that is transferred into the molten weld pool through welding arc. So this type of electrode that itself act as a filler material. There is no additional filler material is required to add in the molten material. The consumable electrode that itself act as a filler material. In non-consumable electrode, additional filler material should be added separately into the molten weld. That's the importance. So consumable electrodes are classified into two types: bare electrode and coated electrodes. Classification of consumable electrode, that is bare electrode and coated electrodes. Bare electrode consists a metal or alloy wire without a flux coating on them. Bare electrode consists metal or alloy wire without a flux coating on them. There is no fluxy coating over a bare electrode. See, the metal passes from electrode to work are exposed to oxygen and nitrogen in the surrounding air. This causes formation of non-metallic constituent that will be that are trapped rapidly solidifying metal and thereby decrease the strength and ductility. That's a disadvantage of bare electrodes. So when we are using bare electrode also consumable electrode. So the electrode get melted and the material is transferred to the molten weld pool through welding arc. So when the material is transferred through welding arc, it is supposed to exposed to oxygen and nitrogen from the surrounding atmosphere and non-metallic constituent will be formed that will be trapped rapidly solidifying weld metal and it will reduce the strength and ductility. So shielding gas should be provided separately. As there is no flux is provided over the bare electrode, we have to provide shielding gas in order to protect the weld pool from surrounding atmosphere. Second one is the coated electrode. Coated electrode consists of flux coating over the electrodes. So flux is basically a chemical component. So flux that will undergo chemical reaction and producing a shielding gas, and it prevent the formation of oxides and help to form slag. See, slag is a very light material when comparing to molten material, and the slag that will float over the weld pool and prevent the contact of surrounding atmosphere from weld pool. Slag also act as a cleaning agent. The slag that will absorb impurities and oxide impurities from the molten material, and after solidification the slag can be removed by chipping operation. So that's the importance of flux coating on the electrodes. So flux coating on the electrode during welding process, the flux undergo chemical reaction and producing shielding gas. Flux also produces a slag, and slag have lighter weight when compared to molten material that will float over the molten material, that will separate the molten material from the surrounding atmosphere, prevent absorbing nitrogen, oxygen from the surrounding atmosphere, and slag also act as a cleaning agent which will absorb impurities from the molten material. See, commonly using fluxes are asbestos, mica, silica, etc. etc. These coated electrodes are again classified into four types. Light coated electrodes based upon coating factor. These coated electrodes are classified into four types: light coated electrode, medium coated electrode, heavily coated electrode, super heavy coated electrode. See the coating factor. This classification is based on the coating factor. So what do you mean by coating factor? Coating diameter divided by coating wire diameter. So that means the coating diameter divided by the electrode wire diameter actually. That is a coating factor. So light coated electrode coating factor is 1.25 to 1.3. Medium coated electrode coating factor is 1.4 to 1.5. Heavily coated electrode coating factor is 1.6 to 2.2. Super heavy coated electrode coating factor above 2.2. So these are the four classification based on the coating factor. Next one, type of flux coating on arc welding electrode. See what are the types of flux coating on arc welding electrodes. Cellulosic, cellulose, wood pulp and floor. Rectile, coating based on titanium dioxide. Basic or hydrogen, controlled electrodes. Coating based on calcium carbonate or calcium fluoride. Iron powder electrode, coating containing iron powder. These are the commonly using fluxes in arc welding electrode: cellulosic, rectile, basic or hydrogen, iron powder electrodes. So electrode manufactured in two length, 350 mm and 450 mm. These are the commonly length of electrode manufactured for arc welding process: 350 mm and 450 mm. So next we are going to discuss about different classification of arc welding process. So first one is shielded metal arc welding process, SMAW process. So you have to understand or study all the short form of welding process. Shielded metal arc welding process, short form is SMAW process. See, this is the figure of shielded metal arc welding process. Okay. Shielded metal arc welding process, otherwise SMAW process, is an arc welding process. So as it is an arc welding process, it is a fusion welding process. The heat required for welding is obtained from the electric arc created between the consumable electrode and the workpiece or base metal to be jointed. Commonly, flux coated consumable electrodes are used in shielded metal arc welding process. See, during welding process, when the electric arc struck between the consumable flux cored electrode and base metal to be jointed, the consumable electrode get melted. The tip of the electrode get melted and material is transferred to the weld pool through the electric arc. The electrode itself acts as a filler material. No additional filler material is required to add to the weld pool. During the welding process, the flux coated over the electrode undergo chemical reaction and produces hydrogen and carbon dioxide that provide a protective cover over the weld pool and separate from surrounding atmosphere. Electrode coating also forms slag that is lighter material than the molten material that float over the molten material, and that will act as a cleaning agent which will absorb impurities from the molten material, and also it acts as a protective cover over the molten weld pool and reduce the cooling rate. After solidification, the slag can be chipped off. See, more than 50% of the industrial welding are taken place by shielded metal arc welding process. That's the importance of shielded metal arc welding process. I will explain once more. Shielded metal arc welding process, it is short form is SMAW process. It's a fusion welding process and it is also an arc welding process. In shielded metal arc welding process, the heat required for welding is obtained from the electric arc struck between the end of the electrode and base metal to be jointed. In shielded metal arc welding process, commonly consumable electrode is used. Flux coated consumable electrode are used. During welding process, when the electric arc struck between the end of the electrode and the base metal to be jointed, the electrode get melted and material is transferred to the molten weld pool through electric arc. The flux undergo chemical reaction and producing hydrogen and carbon dioxide gas that providing a protective cover over the molten weld pool and separate from surrounding atmosphere. The flux also undergo chemical reaction and producing slag that have a lighter weight than molten material that float over the molten material and act as a protective cover for the molten material. Slag also act as a cleaning agent which absorb impurities from the molten material. After solidification, the slag can be chipped off. Almost 50% of the industrial operations are taken place by shielded metal arc welding process. See, in a shielded metal arc welding process, the main parts are a welding machine, an electrode holder, a ground clamp, welding cable, welding machine that is DC or AC source, electrode holder that is connected to the electrode which is used to hold the electrode, ground clamp that is connected to the base metal to be jointed, and a welding cable. See, power source are AC welding transformer, DC motor generator, rectifier, inverter, or also are used as power source in the case of SMAW process. So what are the advantages of SMAW process? Simplest welding process. Equipment is portable and less cost. Carried out in many positions with high weld quality. Welding can be done in automatic. Disadvantage. Slower than MIG welding. Because of flux coated electrode, the chance of slag entrapment and other related problems. Application are used for both fabrication and maintenance. The process find application air receiver, boiler and pressure vessel, shipbuilding, boiler and penstock, etc. So every welding process you have study advantage, disadvantage and application. Two or more advantage, disadvantage, application you have to remember for writing examination. Okay, so this is about shielded metal arc welding process. So I am concluding this section. Today we are discussed about the arc welding process. Arc initiation technique, arc welding electrode, consumable and non-consumable electrode, then flux used in arc welding process, shielded metal arc welding process. Okay, thank you.